Morning everybody, Randy Richard here in the shop. New project today, and it's a rototiller. We use a rototiller quite a bit, and it's a rear tine Troy Built Roto Tiller. We bought it 1982, brand new. Well, I guess I'm gonna have to do some work on it. Biggest problem was, other than the seals are tired, there's lip seals, the shaft is really tired. Here's the shaft right there. This is an 1.25 inch in diameter, but you can see where the seals have worn grooves in the shafts here on both sides. They're pretty bad, and I could weld them up and then remachine, but I've got some stock. I think it's just nicer and easier just to make a whole new shaft. So it's kind of an interesting shaft, tapered on both ends. It's symmetrical. It's 7 inches long, 1.25 inch diameter. It's 3 keyways. These keys are on the tapered part, 3/16 and a 1/4 inch key in the middle. The gear sits right here in the middle on that key. There are bearing, tapered roller bearings on each side of that. And then the seals engage in this area here. The tine assembly, these stick out of the box, obviously, the housing. And then the tine assembly slips on here with a through bolt. So each end is also drilled, tapped, 1/2 inch 20. So nice little project. And we're gonna get you going on it. I'll show some drawings. I made all the measurements and show you how I measured to see what angle these were at. Here's the drawing of the shaft. There's the shaft that we're gonna make. The key's still in the middle there, but that's okay. What I'm gonna do is I'm going to drill this end and tap it, and I'm going to put a little counter bore on it with a 60-degree chamfer on the end for a center. Then we're going to flip it. We're going to do the same on this end, drill, tap, and counter bore and chamfer. And then we'll put it. Then we're going to mount it between centers to do the rest of the turning. Alright, got a high-speed tool bit in there. And we'll just got a nice little bevel on it. Alright, so now what we're going to do is we're going to turn around, do the same to the other end, and we'll adjust it to the proper length also, 7 inches. I chipped the insert, so I reground it. And I tell you, it works. Actually, very nice. Now this is 3/16 stainless. And I'm just kind of whittling down. This is a little too big in the center here. Got it here mounted between centers, and what I'm going to do is I need to turn this down to 1.25 for the whole length. You can see the minus sign there, so we're 3,000 small on that end. Okay, I did a little tweak, and let's see what happens. Okay, let's see what we got. You're not going to believe it, but how about that? That's 0 to 5 decimal places. And I didn't even use a dial indicator. I think we'll leave it alone. I left it at the same RPM and same feed rate. 710 RPM. About, let's see, about there's the middle where the gear sits. We're at 1,250, and I measured that thing over there. It's actually a little over one. The gear is a smidge over 1,250, 1,251 or so. So 1,250, we're good. We're gonna flip it around, finish it up with that, and unless I can figure out if I can cut my taper or not, I might have to check this up and cut the tapers. Okay, I got it turned around, and we're going to cut that down. Do one cut. Oh, good. Okay, we're over here on the small surface plate, and I'm going to show you the three methods I use to measure the angle of the tiller shaft here. So, since we don't know the angles, method one was to get a rough idea was with a protractor. So I just put the protractor against the key, which gives me close to a center line, and set it up there, and I end up with approximately 10 degrees. So now I know it's close to 10 degrees. Then what I did is I measured the shaft body here, which is 1.25 inches, and this taper just fades into the straight section of the shaft. And then I measured the best I could with the calipers. I did not use a dial, and just barely caught the edge there. Yet it's only an approximation. It's not the exact diameter of that, but you know, the very closest I could possibly catch, you know. And let's see what that is. Right there, around 733.733. Okay, and then what I did is I took those two dimensions and drew it on the computer to calculate the angle, and it's very close to 10 degrees. So then, since I know it's close to 10 degrees, and it probably is 10 degrees, why would it be a strange angle? It's easier to manufacture if you know a nice round number, right? So I set a set of gauge blocks up for 10 degrees. That's 0.8682. And we'll set the sine bar up here. Place this on there. And I got a couple magnets underneath here to get it nice and straight on the sine bar. And I picked the better end. This has a better finish on this end, and so it's probably less worn or less imperfections. The other end has some pitting. And I put a couple marks there. They're approximately an inch apart, just so I can be consistent. Yep, they're an inch apart. Test indicator. This is a 1/2 thousandths indicator. And we'll set, at one mark, we'll set 0. Just a little bit. There's 0. And we'll go over here and we'll see what this is. Okay, we're about 2/10 over 0, greater. So this end's a little 2/10 higher. So I'm going to call it 10 degrees. And you can't get much better than that. Now, if that didn't come out like that, you fiddle fart around with your gauge blocks, you know, 1,000th, 1/2 thousandth, 1/10 of a thousandth, whatever, up and down, until you get 0 and 0, or as close as you can here, that 2/10. So then recalculate for that stack gauge blocks for the angle. So this is how I found the angle, and through the magic of filming, boom, here's a drawing. Let me get this out of the way. So there's a nice 3D drawing. I used AutoCAD Inventor to draw this, and our keyways, you'll see here, you can see our keyways. All the dimensions are in. Drilling, threading information, and we're good to go. So we're ready to get her made. So off to the lathe and the mill, we'll get her done. So here's the setup with the sine bar. We're blocked up here for a 10-degree angle, and so we're gonna run the carriage back and forth until we get this, so I have 0 reading back and forth on here, and we just use the compound to set our 0, and back and forth with it. Adjusting tool is really pretty simple to do, and I can see it's already moving away from us, so okay. Start snugging it. Make sure you get your backlash out. So I do it. I take the backlash out each time because I tapped on it, and you don't want to get that screwed up. I mean, because I'm tapping it back the other way right now. So out and back. Well, there, we're going to call that good. That's 0. This is really a very accurate and easy way to do this. It's really not that hard. Just remember to get your backlash out, and you can just go back and forth, boom, boom, 0, we're there. Okay, I got it turned around. Dog works and just reaches plenty of room. So we're going to cut this other end, the taper. I'll show a little bit, and you'll get to see when that's done. I'm taking heavier cuts, 30 thousandths, and I'm cranking a little bit faster here. I'm going to mark that 1.5 inch spot just for safety's sake. Just so we know where it's at. There we go. So we're good. We're just going to touch a little file on that sharp edge. Just do a little teeny polish on it real quick, and we yank it out of there. So here's a new shaft set up on the sine bar, 10-degree angle, just like I did the original one. And I'm reading actually at both ends. And since I didn't change my setup on the lathe, of course it should be about the same. And it is. Over 1 inch, I'm 1/1000th over as far as the on the angle. So Hey, a rototiller tine goes on here. So it's a really not if it's out. Oh, I don't know. I didn't calculate how many degrees that is, but it's not much. So I'm okay with that. So it came out good. Real happy here so far. Real happy. The next will be I'm going to put it in a mill, and we're going to mill. We'll mill this slot here first. That's the easy one, and then we'll have to set it up at an angle at 10 degrees, and to mill these slots here. So some more exciting action. Okay, we got the shaft in here. Let's see here. So on the vise, XY 0 is right here. The shaft is 7 inches long, and it's 1.25 inches in diameter. I came over half the distance. Now, the other key, here's the old shaft, the 1/4 inch key in the middle there, and it's in the middle. So what I'm going to do is, I don't have a center, or what do I got here? So I got a 2 flute center cutting and a 4 flute non-center cutting 1/4 inch end mill. So what I'm going to do is I'm going to come in here. I'm going to spot drill. I'm going to drill a hole smaller than a 1/4 inch, just a little bit here, so I can get my. I'll just do it at one end, I should say. I'm sorry. I'm just going to spot drill, then drill a hole, so I can get my end mill down in there, and we'll just start taking our cuts. What I'll do is, though, is I'll get the flat. I'm gonna come over here, though. I'll get the flat so I get the right depth first, and then I can come down over here and go down through the hole, which makes it a little easier for the 4 flute end mill to get the cut. So that's what I'm gonna do. It's end mill. Now, the hole really only needs to be 1/8 of an inch deep, so. Okay, so I'm back into where the end of the hole's going to be, and I'm over the hole. So now my end mill will easily go down in there. And I'm going to go down. I'm going to go like 10 over, so I'm going to go 135. If I drill that hole, it makes it a lot easier to do this, especially in the middle of the shaft. These are just high-speed end mills. I think I'm just going to use this 2 flute. That looks pretty good. Pretty good. That's a 1/4 inch spotting drill. Let's see. Oh yeah. Should work out. We'll check on the length there. 1.2 exactly. Yeah. Good. Okay. That's done. Now we'll get set up to do these other ones. Okay, so I've tilted the shaft up on the taper of the other end so it's flat on the bed of the vise. These are the same angle on each end, so pushing it down on there makes this one level. Now I'm going to try to line it up as best I can with this keyway. The other shaft, they weren't lined up really that good at all, so this looked like a really bad eye, but I will get these pretty good. So what I did is I've moved over so that the center of the quill is at the center, at the edge of the back, the fixed jaw. And I put a dial indicator on, and I've zeroed my dial indicator on it. Now that's only a half an inch. It should be only half an inch to the edge of the 1/4 inch keyway. And so then I'll come over a half an inch and see how close we are if we have to rotate it at all. If we're at a half an inch, I'm going to call, or really close, we're going to call it good. Okay, that's back on 0. So the quill is now centered over the shaft, and come on down, and I'm within a thousandths or less. But less than a thousand. So I'm pretty darn good. Half inch from there, and even iron it looks real good. So we're going to call that good, and we'll mill the 3/16 keyway up here on this end, and then we'll flip it, or we'll cock it the opposite direction and mill the keyway on the other end. There, I just picked up the end as my X0. Okay, so I got a 1/4 inch spot drill. I'm going to be using a 3/16 end mill. But what I've done is I've accounted for the center of where that 3/16 end mill is going to be. And I'm just going to give a little spot drill. Then I'm going to drill a small hole to help out that 3/16 end mill, which it is center cutting, but this will help. Now I'm just going to drill down there about 80 thousandths, 90 thousandths, somewhere in there. This is an 1/8 inch drill. Let's go over a little bit. See if this end mill will do that. I have to there's the flat. We're going to go about 90 thousandths down. Should be hopefully enough. Perfect little key there, 3/16 key. I think that's going to be just right. Okay. Okay. Second one's cut. I'll pull it out. Smack. There we go. To finish shaft, make new keys. It will be good. Come on, nice. Very happy with that. And my keyways are aligned. So I need to make a couple gaskets here for the rototiller. One for this flange. This is the outer bearing race, and then there's a seal that goes in there. So I already made this one. Goes right on there like that, and that'll be just perfect. So we need to make another one. Thought I'd show you how I do this. They come out pretty doggone nice, so I need a smaller one for this one. So I already measured the OD of this, so I need a radius of 1 3/8. I've already set my gasket cutter, razor blade, actually it's a utility knife blade, and my little pointer. Now that's just a piston fit, there's no magnet or anything in there, it just fits perfect in there, and so I loosen the knob, slide it. This is aluminum and steel for the inners here. I anodized them all. Anyway, this is the center from the other gasket. That's a gasket. It's good for something. Throw it in the box. Now, something like this, it's always really best to punch the holes first. If you can, lay it out. But I can do this gentle enough to get those without splitting the gasket. And because I don't have the measurements, I mean, I don't know the bolt circle. I had figured out, but I can do this without it. So we're looking at 1 3/4, so half plus 3/8, right? So 7/8 of an inch. Oh, that's like at the right there. To double check that. Go. Oh, perfect fit. Then we'll see how the back sides, you can't use the back side for layout really. The 3 holes. So we'll just gonna take the ball peen hammer and just kind of press on those holes and get a mark where they're at. There we go. We got marks where they're at. And I'm just going to take my little punch and punch them out. Okay, punched out. Here we go. Perfect fit. New gasket. Now, on gaskets like this, these thin paper ones, I like to use something on them, a little something to keep them moist, and they'll last a lot longer and seal better. Not that stuff. What I like to use is, there's a couple products. This is a Dow Corning 111 or Dow Corning 4. It's called DC4, DC111. This is a silicone sealant. This is pretty thick, and the DC4 is a little thinner. This is a valve lubricant sealant, but it works great on gaskets like this to seal and keep them sealed and keep them moist from getting too dried out and stuff. So I like this stuff. Just put it in your fingers and you rub it on. Works really good. So we'll just do that. You can see how thick this stuff is. I just moisten both sides of the gasket. And stick it on. Okay, we'll just put these on there. Hopefully I lined up the holes. There we go. Okay. Those are ready to go. Here's a gasket punch set I have. I also have some others, but this is a set. It's pretty nice. It goes from 5/16 up to 1 inch. You got your arbor basically, and the punches with a little O-ring. It just slips right on there. What they're called arc punches. This one's this is a snap-on kit. This one, PGH8A. It's our Blue Point, I should say, but made in the USA, up in Wisconsin. Great. I've had this kit a long time. Great kit. Great. Okay, I've slipped the shaft together with the bearings and the gear. They just slide on. Just a little tapping with the hammer, but they just basically slip right on. Just perfect fits. So that'll be the shaft going in. So I'm ready to put the seals in. I'm going to use this O-ring lube. This is a Dow Corning 55. And just put a little bit on the inner part of the seal to help it slide a little easier. A little bit on the shaft. Okay, we're going to put a little thread sealant. This is Loctite 545. And I'm just going to put a little bit around the edge of this. This will help seal the outer part of this. You'll still be able to get it out. Alright, put a piece of packing tape over it. Let's try this again. So I wiped all that off. Oh, there we go. There we go. I got a piece of 1.5 inch PVC here. basically flush. Okay, I'm going to do the same on the other side now. That's perfect. That's what I cleaned up already. And a little flapper wheel. And a little scrub in there. Okay, all cleaned up. Okay, we got new keys. We're gonna put on anyway. All right, never sees. These things, you know, kind of what I would consider rough service. We use rototiller a lot. Big garden. We have actually 3 gardens this year. One is 40 by 40, one's 20 by 10, the other one's 10 by 10. So, lots of garden space. Tap those in. Bolts, never seized on threads. Well, that part's done.